going to be a busy week. So, wrapping up January here, we'll hop in and see what we're looking at for our programming today. We had a program that was due last week. Hopefully, you're not falling too far behind. I guess I should look at that before I get started on anything. Um, I will have, let's see, this is a B Day Friday. So on Wednesday morning during this class will be a programming workshop. So if you're struggling to get your programs written, you're getting behind, you need to, and a bunch of you turned it in. That's great. But if you need help, you can email me. Some of you have been emailing me. That's great. I'm reading those. I'll send you emails back. I know some sent some emails maybe on Friday over the weekend that I haven't got to yet this morning, but I've seen I have some waiting. But you can email me your program and we'll work on things that way. Or come Wednesday morning and I can help you get over the hump, get you, if we're still trying to get started or you're struggling with what you're writing, come Wednesday morning and we'll work on that. Because that'll just be a workshop time where you guys will just be working and I'll be here to help anyone that gets stuck. And of course, if your grade's below 70%, then you'll be required to be here Wednesday anyway. So Wednesday will be like a programming workshop day for anyone needing help with the programs. And like I said, if you're below 70%, you'll be here because you don't have a choice. But you don't want to be racking up any absences because you can exempt the final if you don't have more than 4 absences or more than 4 tardies in here and an advisory. Don't forget, you need to be going to the advisory. So let me put this up on the screen so we can get started and look at what we had this week. Since we had a program last week, we shouldn't have one this week. We generally not too often have one 2 weeks in a row unless we're right up at the end of a unit. Then sometimes we have one twice in a row. Foundations of programming. Let's take a look at what we have this week. So, I didn't get my program turned in last week. Yeah, see, I was not feeling good Friday. I usually get everything turned in. But this week we will probably have 2 programs in a row in February because we'll have a program and then the end of the unit. But this week we have the logic of and, or, and not. So we're going to add more to our programming knowledge. We'll have like a 5-question thing this week. And then next week we'll write a program called for list. You're going to create lists next week. So that'll be cool. So pay a lot of attention to the lesson today because you'll need to know some of that to do next week's program. Let's take a look here. The logic of many options. So we've talked about if statements and then elif statements, if else statements. Let's see. Rock, paper, or scissors. If you choose rock, you'll beat scissors, but you lose to paper. And you'll also tie with another rock. But of course, that depends on what set of rules you're following, which is kind of like life or decision making. So winning rock, paper, scissors depends on a few things. What you play, what your opponent plays, and what the value you put on those elements, right? So some could argue that rocks could shred a piece of paper, therefore beating everyone. But what if you introduce lava? Now you got rock, paper, scissors, lava. Oh, when writing a program, you get to decide what logic you want to follow. So trust us, you'll lava it. Oh, okay, they're getting a little funny there. So we're going to learn to identify and use compound logic expressions, Boolean logic. We're going to learn to create and evaluate Boolean expressions for making multiple decisions. So let's look at page 2. There's only a few pages on this one. And or not. So let's take a closer look at Boolean logic. We've been using this for a while. There are 3 logical operators that can be used to write compound conditions. So that means comparing 2 or more conditions at the same time, basically. You can use and, or, and not. Search engines respond to Boolean logic. You use it all the time when you go to search on a search engine. That makes it easy to tell Google or YouTube you want to watch videos that contain cats and sloths, but not goats, right? Or perhaps you want information on Sasquatch or Bigfoot, but not Yeti. So you search evidence of Sasquatch or Bigfoot, but not Yeti. So you can tell what you want to search for. In Boolean logic, the words and, or, and not make a major difference in whether a statement is true or false. So let's look at each one of these individually. And. So both conditions on either side of the word and must be true for the overall condition to be true. If you want a pizza with pepperoni and black olives, it has to have both for that to be the pizza you're looking for. Both, because there's an and. If you want a pizza with pepperoni or black olives, then there's 3 different pieces of pizza that will satisfy what you want. You'll have the piece of pizza that has pepperoni and black olives, or you'll have a piece of pizza that has pepperoni, or you just have a piece of pizza that has olives, black olives. Right? So as long as one condition or the other condition is true, then the whole statement is considered true for an or. If you have a not, the condition appearing after the word not must be false. If you want pizza with pepperoni but not black olives, then you get the slice that just has the pepperoni. That has olives, that makes it a not true statement there. So for it to be true, the not part must be false. So when you combine 2 Boolean conditions into one compound condition, each individual condition is evaluated to be true or false. The one before the and or not, and the one after the and or not. So this comes in handy when you write codes that includes multiple decisions, so your program knows when to execute certain blocks of code. So I think you got a handle on it. Let's see. Select the correct options. All right, I'm going to open up the chat because I want to get your input on this. I'll blow this up a little bit, see if I can make it bigger on the screen where you can see it really well. All right, Boolean conditions. I want a number that is both even and greater than 26, but not greater than 75. Which one of those numbers on the screen satisfies that condition? A number that's both even and greater than 26, but not greater than 75. Breland's got an answer. No, I just got an answer. Liliana, yours is not on the list. You have to choose one of the ones that's on the screen. Looks like there's multiple answers, so you can't. Liliana's got some issues with her connection there. It looks fuzzy on hers. So let's see what answers I've got on the screen. I said somebody got 74. Somebody chose 27. Let's see, what else did we choose? Someone chose 30. 74. Wait. Oh, Sierra's rethinking her. She says the wording confused me at 27. Then she says, wait. So let's check our conditions before we hit submit, because I think we need to review that. Don't they all fit except 94? Sarah's asking. Well, let's go back. We have an and a not. First thing, it can't be greater than 75. So we know 94 is ruled out. The rest of them are all less than 75. But the first part is even and greater than 26. So both of those things have to be true. It has to be an even number, and it has to be greater than 26. So 27 is out because it's not an even number. It's an odd number. Right? That's an odd number. So take that out. 18 does not work because it is not greater than 26. 94 is too big. 74 is even. 74 is greater than 26. 74 is not greater than 75. So that should work. 30 even and greater than 26, but not greater than 75. That should work. 26 is even, but it's not greater than 26. It's equal to 26. So I think we've got this. Here we go. Submit. Good job. You got to pay attention to the and means you got to be even and greater than 26. Let's look at the next one. Here's another one. Pizza with mushrooms or black olives. So which pizza we're going to accept that meets that definition? We can number them 1 through 5, so you don't have to type the whole thing. 1, 2, 3, 4, 5. Which pizzas are okay? All right. Thank you, Sierra. Gotcha. So just choose 1 through 5. Which of these pizzas are acceptable? It's probably more than one. 1, 2, 5, 1, 2, 3, 1, 2, 4. Oh, I'm seeing everything. I see 1, 2, 3, 4, 5. If I look at everybody's answers and combine them. Maybe we'll see. I see a lot of people with one. I see a lot of people with two. So I see that a lot. So if we have to have mushrooms or black olives, then certainly a pizza with mushrooms and pizza with black olives. How about the pizza with pepperoni? Uh, with an or, either one can be true. It can either have mushrooms or it can have black olives, or it can have both. So that would work. Pizza with pepperoni, that does not have mushrooms or black olives. So that would not work. So number 3 is that. Number 4, pizza with black olives and pepperoni. Does it have mushrooms? No. Does it have black olives? It does. Now, it also has pepperoni, but it didn't say not pepperoni. That was not on there. So we should be able to check pizza with black olives and pepperoni because it has black olives. Pizza with mushrooms and black olives. It has mushrooms. That's true. Because there's not a not. That's what we got to think about. Walk through the logic exactly. It either has to have mushrooms or black olives, but it doesn't say only. It doesn't say not anything else. So it should be everything except the one that just has pepperoni, because that one doesn't have mushrooms or black olives. So that would be a false. Let's see. Excellent. Yeah. As long as this is true or this is true, it doesn't matter what else the pizza has on it. So we're figuring out how computers think with logic here. All right, let's go to the next one. A word that begins with the letter B or U and, so we got a lot of things here. We got an or and an and, ends with ing or ed. So 1 through 7 this time. We'll go 1 through 7. Boarding, understood, unicorn, surprisingly, demoted, unlikely, and bounced. Woo! So a word that begins with the letter B or U and ends in ing or ed. Ooh, boarding and bounced, I see. So I've got 2 people that said that at least. Oh, 3, 4 people, several people that said this, boarding. Because B, so it meets the or, B or U, and it ends in ing. So, or, there's another or there. It can end in ing or ed. So one of these have to be true. One of these have to be true. And you have to have both a B or U, an ing and ing. Let's see. Who else? They said bounced. I've seen that one a few times. 1 and 7, 1 and 7, 1 and 7. Let's see. Do any of the other ones meet it? So B or U. So we've got the ones that start with B. What about the ones that start with U? This starts with U, but does it end in ing or ed? No, it ends in od. So that one doesn't count. How about unicorn? Starts with U, does not end in ing or ed. It ends with orn. Surprisingly, that doesn't meet anything. It doesn't start with B or U or end in ing or ed. Demoted ends in ed, but does not start with a B or U. Bounced does start with a B and ends in ed. So yeah, it should just be the 1st and 7th. Good job. A lot of you had that. All right. Submit. Good job. Okay. Number 4. A character that is a superhero and part of the Avengers, but is not able to fly. Seems like there's usually some discussion on this one. 1, 2, 3, 4, 5, 6, 7. We got 7 choices again. There's a big discussion over, does it matter if they have an airplane? Well, anyone can fly with an airplane. So I don't think that counts. That you have an airplane, because we can all fly. We can fly. We have an airplane. So superhero and part of the Avengers, but is not able to fly. I know there's lots of discussion on the Hulk. Is he flying, or does he just jump a long ways? Oh, do we not have that many Avengers fans? We don't know for sure. Okay, if we look at the first part, is a superhero and so the first thing is they have to be a superhero. Well, all of these qualify under that definition, right? So this one is true for everybody. Iron Man, Super Spider-Man, Hulk, those are all. And so which ones of these are part of the Avengers? And then after you figure that out, who is not able to fly? We'll see. Iron Man's part of the Avengers. Spider-Man's part of the Avengers. Hulk's part of the Avengers. Captain America is part of the Avengers. Black Widow is part of the Avengers. Batman and Wonder Woman are not part of the Avengers. But now we've got this but. Not. We have a not able to fly. Which ones of these cannot fly? Well, Black Widow doesn't fly. Captain America doesn't fly. Hulk jumps a long ways. I don't think they're counting that as flying. Spider-Man swings. I think Iron Man's the only one that qualifies. Anyone disagree? Anyone else think there's another one? You want to argue for another one? Because I don't know. Maybe they're saying Hulk does fly. I don't know. We'll find out when we hit submit. All right. Submit. Oh, nope. They're saying there's more. All right. Who am I missing? Who do you think they've got? What do you think, Liliana?
It says the character that's not able to fly. Iron Man's the only one that technically can.
Oh, so I did it backwards, didn't I? So
yeah,
you think it's these four?
Yeah.
Good. Let's see. That's a good catch. Good catch. Yeah, not able to fly. See, I was doing and able to fly. Good catch. So what do you think? Is it all four of these? All right, we'll submit. Yes, good job. Wasn't going to trip you up on that. Glad you caught that. So that gives me a lot of confidence you guys are understanding Boolean there. All right, here's our last one. Oh, we got 100%. All right, let me straight this back down a little bit. All right, let's go to our next page and we'll look at some of this in an actual program on page 3. So in Python, we've worked with relational operators to compare two values, right? If homework equals done. If homework equals done, that was the if statements from a few weeks ago. Then play video games. We print that to the screen. Okay, homework's done. But what if you had two or more conditions had to be true? So this would be a compound condition. If homework equals done and chores equal complete. Oh, okay. So before we can play video games, homework's got to be done and the chores got to be complete because we got chores got to get done. Now we can play video games. So in this situation, Python would not print anything. It would take no action unless both conditions are true. Homework would have to be done and chores would have to be complete. So now let's look at or and not. If homework equals done or the chores are complete, you can play video games. That's different than this one up here. This one has an and. This has an or. You can play some video games after you get done with your homework, or you can play some video games after you get done with the chores, but you don't have to have both done before you can play video games. So that's a little different. Little different. In this scenario, you're allowed to play video games if either of these is true, but you don't have to do both. See, that's the or. Now, how about if homework equals done and not? And they put this in parentheses, chores equal complete. Then it will print, thank you for doing your homework. Please finish your chores. So that check to say the homework was done, but the chores were not. So it says, okay, finish your chores. No video games just yet. Doesn't say you can do that. All right. Let's look at some code using this logic we've been talking about. Okay, logical operators. Define our main. So we've got our main function here. We've set A equals 250. So A is a variable. Print facts about A. So if, all right, we got an if statement and it's got an and in it. So if A is greater than 10 and A is less than 75, then we're going to print A is between 10 and 75. If it's not greater than 10 and less than 75, it's going to skip this and go to the next if statement, which they could have done this with elifs, right? We learned elifs would have done this last week. If A is less than 10 or A is greater than 75, then print A is less than 10 or greater than 75. But if that's not true, it'll go down here. If A is not 10, print A is not equal to 10. So it's possible to do all, multiple of these, not all three, just because a number wouldn't fit. But there could be multiple of these because it's not an elif. An elif would be, if this is true, do that. Else, check this. If it's elif, if this was true, it would skip everything else. But we need to check these separately because we may need to print more than one thing. So let's see. A is 50. So it should print A is between 10 and 75. And it should also print A is not equal to 10. Let's run it. Facts about A. A is between 10 and 75. A is not equal to 10. All right, change the value of A and see what happens. All right, let's make it, how about 80? All right, let's run it again. What would we expect? It's not between 10 and 75. It's not less than 10, but there's an or. It is greater than 75. So it should print this. And it's not equal to, and it's not equal to 10. So it should, A is less than 10, A is greater than 75. How about if we just make it 75? A is now equal to 75. Is it going to print anything? Is it less than 10? I'm sorry. Is it greater than 10 and less than 75? Is 75 greater, less than 75? No, it's not less than 75. Is A less than 10 or greater than 75? Right. No, 75 is not greater than 75. But it is not equal to 10. Not. Let's run it. That's the only one. A is not equal to 10. How about if we make it 10? Now this is not going to print because this is not true. The not is not true. This is false. It's also, this is false. A is not less than 10. A is not greater than 10. This shouldn't print anything. Oh, look at that. It's blank. Facts about A, nothing. Because all of these are false. This and is false. This or is false. This not is false. All right, let's look at slide 2. Define main, answer, input, which frozen treat do you like, ice cream or popsicle? So we're supposed to put an A or a B. Now look what they've done in this if statement, because this has been a problem we've talked about. If answer equals A or answer equals A. So whether they capitalize the A or don't capitalize the A, it's going to know that it's true. It's going to know they put A. And it's going to print this little 5 lines. elif, so we can use an elif this time, because if it's not A, then check to see if it's B. But if it is A, we can skip. We don't need to even check it again if it is A. B or B. Small b or capital B. Then print this. And that's it. So it just checks to see is it A or B and then print something. So let's run the program. Which do you like, ice cream or popsicles? I'm going to say a capital A. Capital A. And let's see what it does. Oh, look, it prints a little ice cream cone, a little graphic. Looks like an ice cream with a cherry on top. Let's run that with a lowercase a. I'm just hitting A again. Same thing. Still got the ice cream cone. Let's do a lowercase b. Oh, it made a popsicle looking graphic on the screen. That's pretty clever. Small a, back to the ice cream. Capital B, back to the popsicle. So that's the way you can do that when you're having them put yes or no, or A or B. You can have it checked to see maybe they capitalized it by mistake, or, didn't pay attention to it. That solves the problem that we've had. All right, let's look at this last example. Define main. Level equals 22. Hidden character equals yes. Message is blank. We have a variable called message, and we're going to make it empty right now. Now we've got some if statements. If your level is greater than or equal to 25 and hidden character equals yes. Message, so this is like part of a video game. This is some code for part of a video game. The message that will now change from blank will be, congratulations, you've unlocked the Sherlock achievement. But if that's not true, LF, if that's not true, is your level greater than or equal to 25 and not hidden character equals yes? It's not yes. Message, you missed your chance to earn the Sherlock achievement. Well, if that's not true, how about your level is not up to 25 yet? It's less than 25, but you do have the hidden character. Message, you will earn your next achievement when level 25 is complete. So you've unlocked the hidden character. You're just not up to the correct level yet. And when you get there, then you'll have that Sherlock achievement. Else, which means if none of these are true, keep looking for the hidden character. Because this is, if the hidden character is yes and your level is greater than or equal to 25, hidden character is yes and it's less than 25. Here you've got the level that you need to unlock it, but not there yet. So let's see, our level's 22, but we do have the hidden character. So why would we expect it to print? This is not true, and that's an and. This is not true, and that's an and. So it's going to skip both of those. This is true, our level is less than 25. And hidden character equals yes? Yes, it does. So we expect it should print this one because it's going to tell us what our level is and then print whatever the message is equal to. So let's run this. Your level's 22. You will earn your next achievement when level 25 is complete. That's this message right there. Try putting different values for level and hidden character. Okay, let's say we make it to level 25 now. If level is greater than or equal to 25 and hidden character is yes, we should get this one. Run program. Yes. Congratulations, you unlocked the Sherlock achievement. What if we made it to level 25, but a hidden character is not yes? It's no. You missed your chance because we're up to level. We should have had it by level 25. But maybe we're only on level 24. Keep looking for the hidden character. Because now I'm all the way down to here. So there's some examples of how to use and, or, and not. Let's look at the assignment. Page 4 is just going to say, read the lesson. Practice on page 3 that we're just at. You go there and practice. And let's do the quiz. So next is the quiz. Start. A compound condition contains 2 or more Boolean conditions, true or false. Read this if statement and say which one of these to make it true. That's what we were doing as a class. In the compound condition, both conditions on either side of the and must be true. Is that true or false? What happens when you use not? Which of the following statement tests to see if students have a grade of 70 above, as well as fewer than 5 absences? That's like checking to see if you're exempt from the final. So 5 questions. 5 questions this week. So that's not too bad. So if you're still working on last week's program, any program, you got some time because you only have 5 questions this week. So get this done. You got plenty of time for your next class. You can have these 5 questions knocked out quickly. But that is this week's lesson. That's this week's assignment. It's all about the and or not. So we're adding to our capability in programming. It gives us more choices when we do these if and if else and else and all that kind of good stuff. So, all right, guys, Wednesday, I'll be here for programming help. If your grade's below 70, then I'll try to get all these programs graded today. So that way, when you do your grade checks tomorrow, you'll know where you stand. But if I don't, whatever your grade is in hack is going to be fine. So we'll go off of that. But if you need help, come Wednesday, regardless of what your grade is, because Wednesday I'll be here just helping with programming problems that people are having. So, all right, guys, I'm going to let you go. I got about 10 minutes before Cyber gets in here. Have a great week. And we'll catch you later on.